so I did a little different this time. I worked out all the problems in advance, and I put a copy of this on Schoology, and then I'm just going to kind of talk through what I was doing. I think that might be a little easier to follow than watching me work. But we will see. So here's the original question. So u is going to equal the little guy, so u equals cosine of 2x. Take the derivative of that, which is negative sine of 2x times 2. A decent number of people forgot to do that times 2, which changes the constant that you have to multiply by. So I had to get this negative 2 to be a 6, so multiplied by negative 3. And then doing the substitution, I get negative 3 tan of u. Well, tan of u is like its own animal. So it might be best to just memorize that the integral of tan is this. And if you get stuck, then you have it memorized. If you don't have it memorized, or you do get stuck, you can work through it. This one's pretty tough. This is like a double u substitution. So again, tan is sine over cos, which is sine times cos to the negative first. So this is your u. The derivative of cos is negative sine. And then I need it to be positive, so I multiply both sides by a negative, which gives me the integral of negative u to the negative first. When I integrate the negative first power, I get ln. Then I plug back in the cosine. So the integral of tan of u gives me this, but then there's another u within that, which is the original u, the cosine of 2x. And this is probably the most commonly missed one. It's the toughest one. So you get the cosine of the cosine of 2x here. Second one. So here's the original. So u is this little guy here, so it's 3x minus 1. The derivative is e to the 3x and then times 3. Don't forget that chain rule piece. But you need it to be times 6, so therefore I doubled everything to get it to here. And then I plugged in, added 1 to the power to get 3/2, multiplied by 2/3. So this 2 times 2/3 gives me the 4/3. And then you plug back in place of u. Number 3. So the original problem rewrites as 5/4 x to the 1/4. I think that screwed some people up. And then 15x to the negative 4th. So when I add 1 to the, there's no u substitution here. It's just do one thing at a time. So I add 1 to the power here, it gives me 5/4. Then you multiply by the reciprocal, so 4/5 times the 5/4 out in front actually ends up canceling and just is a 1 there. And then here you add 1 to the power and get negative 3. So multiply by the reciprocal, which is negative 1/3 times the 15 is a negative 5, and then plus c. Number 4, so I made this chart first. So it's at 4 trapezoids or 4 rectangles. It gave me somehow, I can't remember, but it gave me an indication I was supposed to use 4 of something. Let me check. 4 trapezoids. So since I'm doing an interval of 4, and I want 4 trapezoids, each interval is 1. So this is your first rectangle, second rectangle, third rectangle, fourth rectangle. And then for the LRAM, you use the 4 left-hand points. And for the RRAM, you use the 4 right-hand points. Then you average those together. And that gives you 6. Number 5 is a piecewise. So at negative 1 is where the split is. So prior to negative 1, you're integrating x squared. And after negative 1, you're integrating negative x. And then this is pretty straightforward, I think. I mean, it's easy to make a mistake. I don't mean that, but I just mean it's something we've done a lot. So you're integrating, you're plugging in the top, minus plugging in the bottom. So negative 1/3 plus 8/3 is 7/3. And then this part comes out to 0. So you just get 7/3. Number 6, this is probably the most tough mathematically, or just the fractions and stuff was kind of a pain. But not unreasonable. Borderline, getting close to unreasonable, maybe, but I don't think it's beyond what they would ask on a non-calculator. So here's your original. Average value is, the integral divided by the length, so divide by 3, or I think it's easier to multiply by 1/3. And then I'm integrating, so I add 1 to the power, multiply by 1/3 times the negative 1/2 gives me negative 1/6. Integral of negative 2x is negative x squared. You got your endpoints here. So I'm going to plug in the top minus plug in the bottom. This comes out to 1/6 minus 1. So 1/6 minus 6/6 is negative 5/6. this comes out to 64 over 6 minus 16. 16 is 96 over 6. And negative, so then 64 minus 96 is negative 32 over 6, but it was minus negative 32, so it's plus. So these two combine to give you 27 over 6 times the 1/3 is 27 over 18, which is a perfectly valid answer, but I know that going forward I have to set the original equation equal to this answer, so it's a lot easier if I reduce it to 3/2. So then I got to set the original equal to 3/2. So I multiplied everything by -2 to get rid of, I don't want that fraction there, and I also don't want the x squared negative. So then I got x squared, positive 4x, negative 3. Bring everything over to the left because it's a quadratic so that you can factor and solve. Number 7. So this is a u substitution definite integral. So u is this little guy. And then du is going to be 2x, but I need it to be 4x, so I multiplied both sides by 2. I also have to plug in my endpoints. So -1 turns into 2, and -2 turns into 5. And then I'm integrating this. So I add 1 to the power, multiply by the reciprocal of the new power. So 2 times the -1 gives me -2. I'm plugging in 2 and 5. And then I get -2 times 2 to the -1st, and -2 times 5 to the -1st. So it's -2 times 1/2. Minus negative, so plus 2 times 1/5. -1 plus 2/5, and -3/5. Number 8. I don't think this is anything too crazy, so you're integrating piece by piece, and then plug in top minus plug in bottom. So add 1 to the power, multiply by the reciprocal. Same thing here, same thing here. Plug in 2 to all of those, minus, and plug it in 0 will just get you 0, so you can just kind of drop this piece. So I get -4 plus 16/3 plus 2. So then I combine these two. Okay, that's -2 plus 16/3. -2 is -6/3 plus 16/3 gives you 10/3. Number 9, this is the derivative like I call them. So you're asked to take this 4 over t and integrate it and then take the derivative of it. So you end up back here, and then those are your constants of integration, or your limits. So you plug in the top, and then you multiply by the derivative of what you just plugged in. Minus, you plug in the bottom, and you multiply by the derivative of what you just plugged in. And I was fine with that. If you gave me that, I accepted that as an answer. Some people did this, some people took that step, some people went a step further. And this is like the simplified version, but you didn't have to get all the way there to get the points. And then number 10, so I gave you that this whole thing was 5, and that this piece was -2, which means the only way it fits is if this piece here is 7. In part A, I reversed the numbers, the endpoints. That means the answer is the opposite of what it is here, so it's -7. Part B, you got to split up. So whether you're doing that in your head or writing it down, this 5 needs to be integrated. And then obviously the f of x needs to be integrated. So the integral of f of x from 3 to 8 is 5, but I flipped it, so it's -5. And then if I integrate 5, some people will think about this as a height of 5 and a base of 5 is 25, but because the endpoints are flipped, it's -25. Some people will integrate it, plug in and subtract, and get -25. Either way, when you add those up, you get to -30. Part C is just multiplying, so the integral from 3 to 6 is 7, and then 4 times 7 is 28. And then part D, this is like that levels thing we talk about. So if f is the derivative of g, it's a level below g. Well, they're asking me about g, so I have to, and all the information I have is about f, so I have to figure out a way to get from f back up a level to g, and that's integrate. I'm going to use 6 and 8 because those are the x values that they gave me in the problem. And if I integrate f, I get g, and then my endpoints are 8 and 6 still. So then I'm just like working down, and it becomes two sides of an equation. So this is -2, and that's given in the problem. And this would be plug in the top minus plug in the bottom. Well, g of 8 is 10, and then I can solve that through and get the g of x comes out to be 12. All right, hopefully that helps.